We see the silhouette, the unmistakable form of a humanoid robot, stepping forward from the darkness. This is the image that has captured the public imagination, Tesla Optimus. But the headlines, the demonstrations of folding laundry or sorting objects, they all miss the point. The revolution is not the body. It's not the plastic and metal, the actuators and gears. The revolution is the brain. Because for the first time in history, we are not just programming a machine, we are attempting to give it a mind. Not a mind of code, but a mind of data. A brain that learns, adapts, and understands the physical world in a way no machine ever has. This is not just an engineer's story, it's a philosopher's question. We are analyzing the brain of Tesla Optimus, and in doing so, we might just be looking at the code for a new reality. To understand what makes the Optimus brain so different, we must first understand the old way. For decades, the brain of a robot, say on a car assembly line, was a rigid, brittle thing. Its entire reality was defined by a human programmer. If sensor A is triggered, move arm B to coordinate X, Y, Z. Wait 1.5 seconds. Close gripper. This is a programmed intelligence. It is powerful in a controlled environment, but utterly useless in an uncontrolled one. Place that same robot arm in a kitchen it has never seen and ask it to make coffee. It will simply fail. It doesn't understand a kitchen. It only understands its predefined coordinates. Optimus and the entire embodied AI movement is built on a completely different philosophy. It is not programmed. It is trained. The brain of Optimus is what engineers call an end-to-end neural network. This is the core concept. End-to-end means it takes raw photons from its cameras, the pixels, and outputs at the other end the final motor commands, the action. In the old way, these were separate problems. An engineer would write code for object recognition, another for path planning, a third for grip control. The system was a fragile chain of human-made rules. The end-to-end brain is different. It's a single, vast network. It learns the entire process, from seeing to doing, by observing millions of examples. It's not given explicit rules. It infers the rules from data. How does it learn? The same way its sibling, the autopilot in Tesla cars, learns. Tesla doesn't program a car on how to handle every possible street corner. Instead, it feeds its AI, Dojo, millions of hours of video from its entire fleet of vehicles. The AI watches. It sees a human driver successfully navigate a complex intersection. It sees another driver fail. It learns patterns. It learns physics. It learns what to do by watching what is done. Now apply this to Optimus. The brain is trained on videos of humans performing simple tasks, folding a shirt, picking up a toy, using a tool. The network isn't told, this is a shirt. It's shown, this is what humans do with this object. It learns the physics of a shirt, that it's soft, foldable, not rigid. It learns the goal of the action, to make the messy shirt neat. This is a profound shift. We are moving from logic to intuition. A brain, however, is useless without senses. The Optimus brain primarily sees the world through the same set of cameras its car siblings use. This vision-based approach is Tesla's core bet, but vision is just one input. The brain also receives data from its proprioception, its sense of its own body in space. It knows where its arm is without looking. It feels force feedback from its fingers. It knows if it's holding an egg or a steel block. All this data, from cameras, from joint sensors, from force feedback, is fed into the neural network. But it doesn't just react to it, it integrates it. This is where it creates what AI researchers call a world model. It's an internal simulation of reality. Before the robot even moves, its brain can dream or simulate the consequences of an action. If I push this block, will it fall? If I grasp this cup, how much force is needed? This internal simulation is the difference between a puppet and an autonomous agent. A puppet is controlled by strings, that is, by strings of code. An autonomous agent has a model of the world and acts based on its understanding of that model. This kind of world model brain is incredibly complex. It has billions, even trillions of parameters. To train it, you need a new kind of computer. This is Dojo. Dojo is not on the robot. Dojo is the school where the robot's brain is forged. It is a supercomputer custom-built by Tesla for one purpose: to train these massive neural networks on video data at an unprecedented scale. This leads to the concept of fleet learning. In the old world, if you bought a robot, it never got smarter. Its code was static. With Optimus, the model is different. Every robot in the fleet is a sensor. Every human interaction, every success, every failure is potential training data. This data is sent back to Dojo. Dojo processes this data, refines the neural network, and creates a smarter brain. This new brain is then beamed over the air to the entire fleet. This means that the robot you have in your home could go to sleep one night and wake up the next morning with new skills. Skills it didn't have before. Skills it learned from a mistake another robot made thousands of miles away. This is a biological model for intelligence applied to silicon, its evolution on fast forward. And this brings us from engineering to philosophy. When the brain is no longer a set of explicit, human-written if-then statements, who is responsible for its actions? If the brain is a 10 trillion parameter network, no single human understands how it makes a specific decision. It has become a black box. We see the input, pixels, and we see the output, action. But the reasoning in between is a complex mathematical process that is not readable by a human. We are building a brain that learns from human behavior. But human behavior is flawed. It's biased. It's imperfect. What biases are we unintentionally encoding into these world models? The old robot arm on the assembly line had no intent. It simply executed its code. But an embodied AI with a world model has a goal. It has a form of understanding. When its brain is a simulation of our world, trained on our data, where does the simulation end and its own mind begin? This is the syntax of our new reality. The brain of Tesla Optimus is not a complex piece of code. It is a new kind of artifact. It is a statistical shadow cast by millions of hours of human reality. It is an end-to-end system that learns intuition. It is a world model that dreams of physics. It is a fleet that evolves overnight. We are moving beyond programming machines. We are now cultivating intelligences. And like any parent, we must be very, very careful about what we teach them, because we are giving them the keys to our world.